Hi everyone. Today I am going to discuss about Dienone-Phenol rearrangement. So this is the general structure of dienone, that is its constant to double bond and a carbonyl group. So di E-N-E-O-N-E. So this is the general structure of dienone, and in presence of acid it converted to phenol. Okay. So what is the mechanism? What happened? The lone pair of oxygen take that proton and becomes OH plus, right? After that, the double bond will migrate or shift towards the oxygens, resulting formation of carbocation here. So that double bond now shift towards this carbon, generating carbocation over the next carbon. After that, the out of two hydrogen, one of the hydrogen is transferred from the adjacent carbon to that carbocation as a hydride to form this ionic intermediate. After formation of that ionic intermediate, one of the hydrogen is removed and form the aromatic phenol ring. So that the step is known as aromatization, and this is the driving force of the reaction. Every reaction to be happen, some driving force is required. For that Dienone-Phenol rearrangement, the aromatization is the driving force. So this is a simple example how it's happened. So now I am going to explain about some example that contain two different substituent over that carbon. So how you can decide which group will migrate. So here the methyl and COG, any one of the group is will migrate. So how you can decide? So you can see that mechanism. After that migration, there is a development of H plus over that carbon. So this is the species formed if COH group will migrate, or this species is formed if your methyl group will migrate. So now you can decide this will form or this will form. See, the carbocation formed here is stabilized by the methyl group by its hyperconjugation effect, whereas the carboxylic acid group have minus M effect, that is negative mesomery effect, and that minus M effect destabilize the carbocation. So any group that stabilize the carbocation will remain intact and the other group will migrate. So out of this group, methyl group will remain intact and COH group will migrate. So after that rearrangement by the same procedure, it will form your phenol like that. Okay, so now what you have to keep in mind, that stability of carbocation. What is the order of stability of carbocation? That is, any aromatic ring stabilize the carbocation most, then any group showing plus mesomeric effect, then any group showing plus hyperconjugation effect, then any group showing inductive effect, then your anti-aromatic one. Okay, so this is the order you have to keep in mind to determine the stability of carbocation. So now I'm going to explain one more example. See, here is your OH and methyl, right? And this will be your substrate. So in the presence of H plus, what will be the product? So there are two type of possibility as shown in previous example. Like one is this one with methyl bromigrations, or this intermediate with OH bromigration. So how, what do you think? This will form or this will form? See, here the form carbocation is stabilized by plus an effect of OH group, right? But here it is by plus hyperconjugation effect. So you can see in that order aromatic then mesomeric effect. So OH group will remain intact and methyl group will migrate. So what is the product of the reactions? OH here and CH3OH. So what happened when both the group will be alkyl? If you have a substrate like that, here is your CH3 and C2H5. So which group will migrate? So same like two ionic intermediate will form, like containing methyl group and C2H5 group migrated, and one is like C2H5 group will remain and CH3 migrate. So now you can decide which group will stabilize more. So here this group also saw plus H and this group also saw plus H. So which group will show more? So now you can remember one more thing, like higher the number of alpha hydrogen, higher plus H effect. This is you have to remember. Okay, so here if the carbon is that is alpha, so 3 alpha hydrogen. Here how you can write like this? How you can write this thing like CS2 CS3. Okay, so this is your alpha, so 2 alpha hydrogen. So here it is 3 alpha hydrogen, here it is 2 alpha hydrogen. So this group will stabilize more the carbocation as compared to this one. So what is the product? In presence of acid, it will form CH3 over here, C2H5 over here, and OH. This is the product you can expect. So one more reaction based on the same mechanism, like dienol benzene rearrangement. Okay, so from the name you can imagine that the substrate contain di-ene and oil, that is phenol group. Okay, oil comes from phenol groups. This is the substrate, and in presence of your acid, it will form benzene. How it will form? The same reaction, same mechanism. Like initially the OH accept that proton, and we can know that the water is a good leaving group. It will leave minus H2O, generating a carbocation here. Now this double bond will shift to the next carbon and generating the carbocation here. Now here two hydrogen. One of the hydrogen will migrate to the next carbon as a hydride to form this ionic intermediate. After formation of that, one of the hydrogen is removed and form benzene. So here also the driving force is aromatization. So if you think the video is helpful, so you can like my video, and I am going to discuss all the name reactions one by one. If you have any doubt or comment, you can comment on my comment box. I am going to solve your doubt as soon as possible. Thank you.